All right, next up, we're going to learn about one of the most important numbers in chemistry. It's known as the mole, and it's just equivalent to a chemist's dozen, right? So we know that 1 dozen is equal to 12, right? So whatever you're talking about, a dozen eggs, a dozen cars, whatever, it means 12 of something. And so 12 for chemistry is way too small of a number. And so we need a much bigger number, but it can still represent some number of things, right? So like a dozen represents 12. We're going to have a mole, which is going to represent some other number. So a mole, M-O-L-E, it's also abbreviated M-O-L, so drop the E. 1 mole is equal to 6.022 times 10 to the 23. This is not an exact conversion. So this digit right here has only 4 sig figs. If you look online what the real mole number is, you'll see a whole bunch of numbers behind it, but that's the level of precision that we're going to go with. This is also known as Avogadro's number, and again, it has 4 sig figs. But just like a dozen means 12, 1 mole means 6.022 times 10 to the 23. And if you write that out in long notation, you'll notice that that is just an absolutely massive number. And we need such a huge number because our atoms are just absolutely so tiny. So for example, if you had 1 dozen basketballs, I'm just going to call them B-balls for short, how many basketballs do you have? Right, and obviously you can just say 12, but if you show it in the mathematical way, you have 1 dozen basketballs, and then you'd use your conversion factor, right? 1 dozen is equal to 12, and so you have 12 basketballs. Well, what if instead of 1 dozen, we had 1 mole, and then this dot mean here, that just means repeat what's above it, right? So we're just going to repeat this question. If we had 1 mole instead of 1 dozen, how many basketballs would we have? So we would just write 1 mole of basketballs and then use our conversion factor, right? Our conversion factor is going to be 1 mole down here and then 6.022 times 10 to the 23rd. And then obviously it's just 6.022 times 10 to the 23rd basketballs. But you see how the mole is no different than just saying a dozen. And then I've got a visual representation of this for you. So over here on the left, we have a little picture of Earth, and then we have a picture of 1 mole of basketballs. And so you can see if you had 1 mole of basketballs, you'd have a a large ball of basketballs the size of Earth. So you can see that 1 mole is just an absolutely large number. However, on the right side, we have 1 mole of each element here. And what we can tell with this one is it's not that much, right? You see the copper wire, that's not a huge copper wire. None of the piles of these metals or compounds or atoms are that large, right? So it's not that much. So while the mole is such a huge number, atoms are so tiny that 1 mole of any specific atom isn't really that much. So let's just do some more conversions. What if we had 4.2 moles of helium atoms? How many molecules or how many atoms, right? And so again, we would just do 4.2 moles of our helium, use our conversion factor. 1 mole is equal to 6.022 times 10 to the 23rd. Plug that into our calculator, and then you get 2.529 times 10 to the 24th. Notice that this number right here has only 2 sig figs, so our answer needs to only have 2 sig figs. So we're going to round it to 2.5 times 10 to the 24, right? Notice now it's to the 24 because it's a larger number than 23. And then notice that you always want to write in correct scientific notation. So this shouldn't be 25 times 10 to the 23rd. That'd be incorrect, 2.5. And then in this case, this would be, helium atoms. And then we could do the reverse as well. What if we had 8.45 times 10 to the 26 atoms of, let's say, copper? How many moles do we have? So if we have 8.45 times 10 to the 26 atoms, We can again use our conversion factor, but this time we're going to flip it around. We're going to want atoms down here and then moles up here, right? So 1 mole is equal to 6.022 times 10 to the 23rd of whatever you're talking about. So in this case, since we're talking about atoms, we're going to put atoms down there. And then we just go ahead and do the math, and then you get 1,403.19 moles. This number right here has only 3 sig figs. And so our answer should only have 3 sig figs. Our uncertain digit is the 0. So we have to write this as 1,400 moles. And then we have to either underline that 0 to indicate that it's a significant digit, or we could write it in scientific notation as 1.40 times 10 to the 3rd moles, right? So make sure that you indicate that that 0 is indeed significant. But other than that, you can see how we can convert just from dozens of things just to moles of things. It's the same thing, just a different number.